We've talked about some of these terms already, but let's get some formal definitions and some examples with using this vocabulary related to algebraic expressions. So, parts of the algebraic expression that are separated by addition or subtraction are called terms. So, if I have this algebraic expression here, what we could do is just kind of find the chunks between plus and minus here. So like we have this 3x to the 6th power, and then plus 2x to the 4th minus 3x cubed plus x minus 18. So each of those are terms. So this expression here has 5 different terms, and we would have 3x to the 6th, 2x to the 4th, negative 3x cubed. So notice that when it's addition or just a positive number out front, it stays positive, but when it's subtraction, we actually want a negative coming through, which again, we haven't quite got to negative numbers. We'll talk about it a lot more with integers, but just kind of want to put it in there so that we get some context for it for when we get to integers. So with subtraction, that negative's attached there. We have a positive x and then a negative 18. So there's our list of terms. The constant term is a special term that has no variable factor. So in this case, it basically doesn't have x. So here we have that minus 18, which is just a number, and that would be our constant term. So negative 18 would be our constant term there. So that's how we find the terms and then the constant term amongst those. Factors we've talked about before as the values that multiply together to make a number. The coefficient is the number that multiplies to variable. So, with this expression here, the coefficients, let me just undo that negative 18 there. So coefficient is going to be next to our variable factor, and it's going to be the number part. So like 3, 2, negative 3. And then here where it's just x, what we want to do is imagine there's a 1 right there. So 1 times x. So 1, and then 18 is the constant term, so it doesn't have a coefficient. So these would be our coefficients. They're sometimes called the numerical coefficient for each term. So again, if it's subtraction out front, we're going to have that kind of negative attached to it. So that would be part of our coefficient. The degree of the term comes from the exponent value for the variable. So the degrees, we'd have a degree of 6, 4, 3, and then here is another hidden one right there, and 1. And the constant term technically has a degree of 0. I won't go too far into why, but basically there's a hidden x to the 0 power there. We'll talk about that more when we get to exponents, but degree 0 for the constant term. So let's go and actually list these. So list the factors of each term. So like 3x to the 6th, let me start by listing out the terms. So we have 3x to the 6th, 2x to the 4th, negative 3x cubed, x, and negative 18. So if I wanted to list out the factors, this 3x to the 6th is coming from a 3 times x to the 6th power. 2x to the 4th is coming from 2 times x to the 4th. So all we're really doing here is showing the multiplication that's separating this coefficient part and the variable part. Now x is just x, and negative 18 is just negative 18. Okay, identify the coefficient of each term. So we're going to have coefficient of positive 3, coefficient of positive 2, coefficient of negative 3, with just x. Remember, there's like this 1 multiplying out front, so that has a coefficient of positive 1. And then negative 18 does not have a coefficient because it does not have a variable part. So we leave that out. Okay, identify the degree of each term. So that's going to come from our variable part and looking at the exponent. So that first term is going to have a degree of 6, degree of 4, degree of 3, degree of 1, because there is an exponent of 1 right there. And then constant term is a little different, but it does have a degree of 0 technically. All right. So this is something that I mentioned in a previous video of when using the order of operations and how following PEMDAS strictly, there's a lot of steps to it, especially with something complicated like this example here. So here I just really want to emphasize this other way of doing the simplification, and it's by simplifying by terms. So if we can identify the separated terms, that can help us kind of see the different spots that we're applying PEMDAS all at once, rather than looking across the entire expression. So what I mean by that is that, like, here's this plus symbol on the outside. So here's a term, and there's subtraction there. So there's a term. So what we can do is apply PEMDAS to each of those separated terms at the same time. So this 20 over 5, that's just division, so we can simplify that to a 4. And then plus, now in this whole term here, it's a big term, but we can go ahead and just simplify, let's see, parentheses, but then a second set of parentheses. So that middle term is going to have 3 squared. And then what we have, 1 plus 3 is 4, minus 2, and close those parentheses. And then our final term here is a minus 2 cubed. So it's just simplifying the exponent, which would be a minus 8. So that takes care of a few steps in one. It simplifies all 3 terms. And then at this stage, what we're really focused on is just simplifying that middle term and getting that down to a single number so that then we can combine them. Because if we think of our 3 terms now, that 4 and that negative 8, those are done. There's nothing else to do there. So I don't need to focus on those anymore. Now it's all about applying PEMDAS to that middle term. So this 4 and the 8 are just going to keep staying the way they are until we get to the end. And let's see, 9 times 2 is 18. And now we can just go from left to right. I'm going a little fast with this one because we've actually already solved this together in a previous video, but just want to show another way of accomplishing that using terms in case you like that way best. It can be a nice way of applying PEMDAS without so many separated steps. Sorry, and just to go back to one thing, as I was going through that, I was thinking more about this last problem. The coefficient of the constant term. Because like I was saying, it could be thought of as this breakdown of the negative 18 times x to the 0 power, so that's where we'd get the degree. And that would actually mean that our numerical coefficient, I'm sorry, I know I said there isn't one, there is, and it would be just equal to the constant term. So when you have the constant term, the coefficient is just the same number, degree is equal to 0.